Friends, let's play an interesting game. I'm going to show you 3 objects, and they are as different from each other as you can imagine. Different in shape, size, and function. But there is something common to all of them, and it has to do a lot with chemistry. Watch closely. This little disc, so light and wafer thin, but what amazing capacity it has to store music, videos, and of course, data. This tennis racket, so light, yet so strong, capable of withstanding the power of the delivery of a tennis pro. Imagine the power of a serve, turning man into a bird, soaring in the skies with this incredible fabric. Light, strong, and beautiful, just like the wings of the bird. Okay, friends, tell me what is common in all these things that you saw.
I think they all are a lot of fun.
You bet, Dilip. And they are made from a material which is so important to us that we cannot imagine a modern life without it.
Material? You mean to say they are all made up of the same material?
Not really. These wonderful things and thousands of other like them are made from materials which are broadly known as polymers, the products of polymer chemistry. Polymers are materials made up of simple molecules joined together in a repeating chain. Polymer products are used in a number of industries, including health, medicines, clothing, transportation, housing, energy, electronics, amongst many others.
These polymers are light in weight, it is having very high strength, and this could be recycled for a number of times.
Polymer scientists work with a range of products that include plastics, synthetic fiber, paints, adhesives, synthetic rubber, packaging materials, and many more others. Since polymer chemistry is highly application-oriented, there is a large scope for product-based research.
I work on colloidal suspensions, and they are beautiful suspensions which look like this. They scatter light, and you see there are rainbow-like colors in the system. Why I study this system is to study the properties of these colloidal gels. You see this, I invert this bottle and it's not flowing. So it is something like your toothpaste, which doesn't flow from the tube, you know, but when you press the tube, it actually comes out. When you put it on the toothpaste, it is again solid. When you again put it on your and when you brush, then it is again flowing. So all these things are studied at the lab scale level first before it goes to the industry where, you know, actually these tubes are filled, you know.
With the advent of green polymers and emerging interest in material sciences and nanotechnology, new frontiers have opened up for polymer chemistry today.
I chose polymers as my branch because of basically 2 reasons. First, because as a polymer scientist, I could make an impact upon the society. And secondly, obviously because of the lucrativeness of the career.
What excites me about chemistry is that I am making a new molecule. So everything about chemistry is actually synthesizing a new material. So it's the carbon-carbon bond. So, you know, it's like you're working in the lab and you're actually making new materials which are, you know, going to help the people.
Believe me, polymers is creating wonders in the world, and it requires wonderful people like you to come in.
Considering these applications and wide range of potential, this would be very important branch in future, and I think a new generation should concentrate and come into this area for better and brighter future.